everyone, it's Judy Warner. Welcome to this episode of our DesignCon 2025 Pre-Game Tailgate Party. Today, I'm joined by our MVP, Matt Burns of Samtec. We're going to talk about innovation, AI, which is what everybody's talking about going into DesignCon, and how that's going to impact engineers like you and give you tools and resources for you to get ahead of the game. Now let's jump into our conversation with Matt Burns of Samtec. Hi, Matt. Happy New Year. Great to see you and excited that you're going to be my first guest for our DesignCon 2026 pregame series. So thanks again for joining.
Judy, it's always a privilege to be with you. Welcome to 2025. And as always, I look forward to spending some time with you. DesignCon is always a great way to kick off the high-tech, high-speed year. So look forward to talking about what Samtec's focusing on for the event.
Yeah. Well, I think I've said it before, but you're the one that gave me the whole idea about doing a pre-game DesignCon series because you said it was the Super Bowl of electronics.
I didn't come up with that quote, but one of our Samtec teammates did. So I'd like to take credit for that, but I have to give credit where credit's due.
Well, wherever it came from, I latched onto it, and that's how this became, that we're pre-gaming. So I have a logo with people younger than us with solo cups pre-gaming. So that's what we're up to today. We're drinking from the fire hose, buddy, not a solo cup.
No problem. I like it.
So let's talk about, as we dive into the new year and dive into a new DesignCon, you're on the front lines of technology speeds. You're talking to lots of people in the industry. So what are the technology trends and things as we go into this year's DesignCon, and what are you seeing as the technology drivers this year?
No, that's a great question. Great way to start out. And I would say at a high level, macro level, Judy, I've never seen innovation ramp up so fast. I've been in this industry 25 plus years. I'm starting to date myself, but that's just the reality. Uh, and with everything that's happened in AI over the last couple of years, whether it's Gen AI or inference or training, just the entire ecosystem has just hit the acceleration pedal and coming up with new solutions. And it's not just product; it's innovation, it's R&D. It's how do I design my chips to go faster? How do I design channels to go faster? How do I process data faster? How do I cluster, dozens, hundreds, thousands of GPUs to handle these, ever growing AI foundation models? So that's really been the big thing in the industry, and it's everyone's saying about it, right? It's the IC vendors, it's the semiconductor providers, it's the IP, it's EDA, it's test and measurement, it's interconnect companies like Samtec. That's really the biggest trend, and I think everyone's struggling to keep up. They have, we're doing it because we have to. It's a you talk to a lot of people. This whole AI ecosystem is a once in a lifetime or once in a generation
Yeah.
inflection point. But that's it. And behind that, obviously, you and I have talked earlier about how designs get smaller, faster, denser. And, that's kind of an underpinning for what's happening with AI. So I think the biggest driving trend in our industry, the last couple years, and I don't see it changing in the foreseeable future. So obviously it's can continue to morph, it can continue to evolve, but having more AI processing capability and access to the latest and greatest models is going to define the high tech industry for the foreseeable future.
Well, you are saying, I was talking to our mutual friend, Steve Sandler, who's been in it 40 years, so he
Yeah.
makes us feel good about ourselves. Um, and he's saying that across his whole career, he's never seen this kind of velocity. And I thought we were fast and pushing it all the time before. So I'm trying to get my head around, and it, like you said, it's not just chip level, right? It's chips attached to boards, attached to cables, attached to blah, blah, blah. So
Yeah.
this whole ecosystem has to be brought up in this unprecedented speed. So anyways, I'm getting ready to drink from the fire hose at DesignCon because I think I'm going to see stuff that I didn't even see coming, right? Because I only go to 2, 3 trade shows a year, and you're in it all the time, year round. So it's fascinating, and I'm excited to talk to you more about the way Samtec's leaning into that and the kind of things you're coming up with. So, for our audience, they're design engineers. So, what are the challenges because of this velocity and the R&D and everything that's going on? What are the design challenges they're facing? And if you have any thoughts about what's coming, I think our audience would appreciate a little heads up.
Yeah, I would say, it's been interesting over the last couple years kind of watching the design challenges evolve with where technology's gone, right? If I say, let's say pre-G, I'm just gonna just look at recent history. You look 3 years ago, 3, 4 years ago, we're still in the middle of the pandemic. It's sort of a pre-Chat GPT world.
Mhm.
Um, the focus was speed. How can I get faster, quicker? And that was evolving every 2 to 3 years, plus or minus.
Right.
I don't think that trend stopped, but because of AI, because of the exponential growth of AI foundational models, you're talking about models that have billions, hundreds of billions, billions, sorry, too many zeros, multiple billions of parameters per system. And, each of those single parameters requires a transistor to go back and forth. So you're talking billions and billions of transistors, parallel processing. So it's not one GPU, right? Or XPU
Right.
or AI accelerator. It's multiple, right? You're doing the parallel processing that x86 CPUs just can't handle. So not only is it faster, but it's how do I scale these platforms to be able to handle these models quickly? And so far, the GPU solutions, the XPU solutions on the market are really what's leading it. In addition to speed, uh, if you look at the TDPs of these chipsets, they're approaching 2 kilowatts. 2 kilowatts for a single chip, right? So, okay, I have to route 200 gigabit data in a PCB the size of a laptop. I need to get 2 kilowatts in while also getting rid of all that heat. It's not convection, right? It's not conduction. It's not a fan. It's liquid cooling.
It's liquid cooled.
Yeah, so whether that's a cool plate or a, a CDU that's attached to the AI chassis, it's really changed the game in terms of how system engineers, electrical, optical, software are. It doesn't matter, right? Anyone that's in this ecosystem really has to change their thought process. The most important design consideration is how do I get all that power in and how do I get all that heat out, while at the same time pushing the envelope in terms of speed performance. So
And
it's
keeping
not
it light and small.
exactly. So it's not just it's not just a signal integrity challenge anymore, Judy. It's signal integrity, thermal, power. Some of that's PDM, but it's also power delivery. It's material science. It's working with, is it immersion cooling? Is it liquid cooling? So the ecosystem of engineers has evolved and grown exponentially just because of the design challenges you have trying to support AI. So again, high speed, but more importantly, power in and thermal out. So from what I've seen in the trade shows, DesignCon, supercomputing, whatever, the ones I've been at over the last 12 months, that's becoming the theme. Now, it's one caveat I would throw in here is I was at a trade show, I think it was supercomputing, and someone kind of joked that every time you put a new data center up to design an AI centric data center, you need to put next to a nuclear reactor. And that's happening, right? I mean, I don't know if you saw this in the news, but I think it was September-ish last year. Microsoft is working with Constellation Energy to bring 3 Mile Island back online. Uh,
No.
yeah. Now, grant it's not going to come on the line until about 27 or 28 because of the legalities and everything they have to go through to bring the power plant back online. But that's the reach that the hyperscalers are going through to support their power needs.
Their power.
Oracle's working with nuclear reactor startups to create microcells to support their data center. There's all sorts of data points along this standpoint. So that's where the
So in other
industry's
words,
going.
we're not gonna count on wind farms. Sorry.
They're a piece of it. It's
just
that.
I just I I'm sorry, I can't
That's
help but
okay.
be sarcastic, but you know, I there's no way with these kind of power demands
Yeah.
that we can rely solely on green energy. We're just not there yet. Maybe
Yeah.
someday,
Yeah.
but it's just I think nuclear. I mean, there's just so many people talking about it, and
Yeah.
sorry to offend you green energy people, but these power demands are so vast.
Yeah.
That's
Eh,
wild.
yeah, and I think that just goes to, the while, we're maybe referring to this maybe slightly sarcastically or slightly tongue in cheek, it does illustrate how disruptive everything with AI has been, because it's not just designing the chipset to get the highest performance out of it, power in, power out. It's how do I create the data center where I can put 10,000 of these chipsets or 10,000 of these shells within a specified footprint, power, whatever. So it's becoming more complex, and it's going to continue to do so. One last data point. I don't know if you saw this or not. Microsoft mentioned, I think over the weekend, first weekend of the year, they're going to spend $80 billion just in 2025 ramping up data center production. $80 billion capex for investing in data centers. They're one of
Right.
8 to 10 hyperscalers that need to
Right.
invest that much.
Mhm.
So
Mhm.
it's hundreds of billions of dollars each year, $250 billion each year being invested in this space around the globe. So that really underscores the challenges that designers, system developers, et cetera, have to consider. It's not just about putting in the schematic, making a PCB, and making sure the thing works. It's this entire ecosystem that really has to drive things. So I think that's, I'm getting long winded on the topic, but that's going to be continue to be the trend going throughout
Yeah.
25.
Well, I think it's a fascinating topic, and I think our listeners wanna know, and get a grasp, of what's going on. It's happening so fast. It's actually hard to keep up with. And I think EDA tools are gonna have a
Oh,
big
without
piece in
question.
this, and it'll be
Yeah.
interesting, to see how that's gonna morph as well. Um, I know not too long ago, specifically to what Samtec is doing, and thank God for flyover cables, right?
Yeah.
It's
Yes.
like, but I know you introduced a product called Scifly, which I think is a really fun name. Why don't you tell us a little bit about that and for your little piece of the ecosystem, how that comes into play?
No, that's a nice transition because you can talk about AI for hours and days and never cover everything. So thank you for keeping us centric for where we're supposed to be, 2D. Going back to speed, that's the one part of this whole ecosystem where Samtech contributes to. It's not only the cables, but it's the signal integrity expertise as well. So
Right.
thankfully, as we're seeing this transition from 100 gigabit to 200 gigabit solutions, in a single lane, that's where uh, flyover technology, is a differentiator. The biggest reason is, if you look at ultra low skew twin X solutions that we have right now, differential pair skew is 3.5 picoseconds. We're getting down to 1.75 picoseconds on next
Wow.
generation solutions. The loss of the cable continues to get smaller, even as Nyquist gets bigger or higher. We're roughly one third to one fourth the loss of PCBs, so we can extend the reach of the signals over longer distances. And if you're trying to route signals, just think of a traditional networking chassis or blade. You're trying to take it from the networking IC to the front panel. That may be up to 18 inches or a half meter of cabled solution. So trying to find connectors that fit on the front panel, which are typically an MSA, maybe it's an OSFP, an OSFP-XD, a QSFP, whatever. On the back end, the question that comes up at higher speeds do is it possible to integrate the twin-X cable directly on the package of the IC, or do I put it right next to the switching ASIC, or GPU or whatever, depending upon the application?
Mhm.
So that's a question that we run into. So what we've done with Scifly is uh, the next generation solution targeting 224 really supports both approaches. So we're working with leading chipset designers in Silicon Valley that will actually take Scifly and actually put the cable comes in, it's connectorized, connector sits directly on package right next to the IC. It's a much more complex design because it's not just an IC being placed on the PCB, but it's the die going on the package. Our connectors are right next to the die. We have to work with their packaging vendors to come up with a solution that secures all of that to the same substrate. Put the solder balls on the substrate, and then drop it down on the PCB.
That's amazing.
It is. So you'll see some information from us on next generation prototypes of this solution, working with our tier one vendor at DesignCon. So we're really excited about the opportunity. We're really excited to see the applications, and it's pervasive. It's not just networking, but it goes into storage and servers and AI and things like that. Additionally, we also have the near chip version of Scifly, so that in instances where the design is too complex for a connector on substrate application, we have the near chip or ASIC adjacent solution that keeps the trace length from the ball to the connector maybe a half inch or an inch, depending on how the trace goes. So in those type of applications, it's all about how do I optimize the breakout region from the signal on the chip to the breakout region on the interconnect. How do I make that interconnect not only support 200 gigabit plus performance, make it small, make it dense, make it reliable so that it can have multiple mating cycles. That's really what Scifly is designed to do. So we have Scifly for interconnect on substrate, and then we have the near chip component version that allows for both approaches. So we've demonstrated Scifly reaching 224 gigabit. We actually worked with, this is public, I can mention this. We work with Synopsys at Supercomputing, demonstrating their latest 224 gigabit IP with a 1 meter long version of Scifly. The bump-to-bump channel was 40 dB at 56 gigahertz Nyquist, and we had a prefect BER of about E to the minus 9 on it. So we're confident that this is going to be a game changer for a number of ASIC to front panel or ASIC to backplane applications, and we're really excited to talk about it at DesignCon, demonstrate the solution with our chipset partners, and help the industry to adopt it.
Well, one of the cool things about you and I doing this every year is I think about what were we talking about last year? And it's like now you're just like, oh yeah, 200 gigabits per second, whatever. Last year we're like 200, 224, and it was just becoming viable, right? So a year later, you're talking like, oh yeah, that thing, like where are we with 224? And then in a bit, I'll ask you about looking ahead since you're on the front lines of all this stuff.
Fair enough. No, 224, 200 gigabit is still ramping up, right? I mean, there's solutions on the market that have been publicized by the solution providers. Some of that's in the AI space. We're starting to see it come out of the network space a little bit as well. So 224 is reality. Is it widespread? Do we have widespread market adoption from all the equipment vendors in every single data center application? No. We'll probably see that over the next 2 to 3 years. Uh, Even though we have production-ready solutions ready to go, there's production-ready solutions available on the market, and there has been for probably the last 12 months, plus or minus. I'd have to look at product release schedules from providers. But 224 is going to continue to ramp up. You and I talking about it for 5 minutes, Judy, make it sound like it's trivial, but it's not. The solutions that
No,
we're
it's
working.
not.
Yeah,
Last year was
yeah,
like, we're gonna have something in the booth and it actually works.
yeah.
It was, an anecdote, but now you're saying we're way down the road. It's not widespread adoption. It's still a lot of stuff's, you know, doesn't run at that speed. It's novel and it's interesting though, and it is no small thing that we can do that.
Mhm. No, it is, and, it's you look at the contributions from, like I said, we talked earlier, I know this is an entire theme of your entire podcast series, is that it takes a village. So you mentioned the EDA vendors, interconnect obviously from companies like Samtec, silicon vendors, The test and measurement guys, the Keysights, the Rodian Schwartzes, the Enritsus. Sorry,
Mhm.
I'm not trying to not mention anybody, but my brain just went south on
Yeah, no, it
test and
is the
measurement vendors.
ecosystem,
Yeah.
right? It's the
The
representative of the ecosystem.
Yeah, the laminate providers, et cetera, et cetera. They're all innovating.
Right.
They're all moving forward,
Mhm.
and everyone's working together to come up with these solutions that make sense where everybody has their differentiation. So I
Mhm.
think you're gonna continue to see 224 to ramp and become more and more of a reality in 25. Um, we see it with our Scifly solutions. We see it on the front panel with OSFP and OSFP XD. Uh, you know, there's there's increasing amount of chipsets available with 200 gigabit transceivers, FPGAs, GPUs, CPUs, 800 gigabit Ethernet, 1.6 terabit per second Ethernet is reality. 8 by 200 obviously is giving you the port speeds that Ethernet's working on. So we're there. It's over the next 6 to 12 months, though, you're going to see it ramp to, full scale adoption and go from there. What's interesting too is that I always tend to think of AI slash data center as the tip of the spear in terms of market
Mhm.
performance. But behind that, and maybe this is just a side point, we're starting to see faster speeds in embedded. You know, you
Oh, yeah,
we tend to
embedded
think
is
of them.
huge right now.
Yeah, we tend to think of embedded as gigabit, single gigabit per second. But when you look at the FPGAs from Altera, when you look at the FPGAs from AMD, they're 56 gigabit, they're 112 gigabit. So, what was bleeding edge in the data center, call it 4 or 5 years ago, it's bleeding
Mhm.
edge for the embedded ecosystem. And,
Mhm.
if you're working with an embedded engineer that's used to working on 10 gigabit design, moving up to 50 gigabit is not trivial.
Nope.
That's trivial for a data center person, but if I'm someone that's in factory automation and I gotta enable or mil aero or commercial satellites or something along those lines, and you need to support those type of data rates, all this ecosystem SI concern becomes a new reality for new applications. So,
Mhm.
um, it's interesting. It's a
And
fun
so does
time for
RF,
innovation. Oh,
right?
yeah, without
Eh
question. We
eh
didn't even touch that.
yeah, which is a whole other, mess for design engineers.
That's for
It's like, "Sorry, you guys, we just keep throwing more and more on these guys and gals' plates," and I'm like, you know, anyways, I don't wanna wax too heavily on that because I will. I just think, "Wow, how do we support these folks," right? The best I can do is make a podcast with people like you. Um So, for a moment, I'm going to give you a shameless plug moment. I know you're unable to be at DesignCon this year, and I'll miss seeing you. But why don't you tell us specifically about the things Samtec is doing and showing at DesignCon so those that are attending will know to look for those things? I know you often do a lot of presentations and demos in the booths and all of that. So, talk to us a little bit about that.
Yeah, so, first and foremost, we talked about the, demonstration of Scifly HD. So I think
Right.
that's gonna be one of the biggest, demos that we have in the booth, but we have a full 20 by 40 space. It's booth 939, so we encourage everyone to come visit us, at the show. Um, we've got 6 or 8 different types of presentations ranging on topics from, PCI Express and PAM4. PCI 6 is obviously 64 gigabit per second PAM4. PCI 7 is coming out later this year at 128. What about 256? PCI 8 is going to come out. PCI 6 will start working on that eventually. We've got the who's who of SI luminaries. The Scott McMurrows of the world, the Rich Mellitzes, the Brandon Gores, the Steve Kruzwicks, the Jignesh Shaws. So we have a number of technical presentations where these thought leaders, these luminaries, will be presenting their viewpoints, their study, their research, their work at the show. We'll also be demonstrating, other solutions that we have. You mentioned RF. Something else that we're really excited about is our next generation Bullseye platform.
Mhm.
Bullseye is a solution that we've had on the market for, I don't know, 15, 20 years. It's really designed as an SMA replacement. So, if you think about an IC characterization board with dozens or hundreds of transceivers. If you put SMA down for all those lanes, you're talking, dozens or hundreds of SMAs. It becomes bulky, it becomes expensive, it becomes, it's just a challenge to be able to attach and reattach the cables for those solutions. So, Bullseye basically gives you 4-to-1 space savings, as well as giving you phase match RF cables, allowing you to terminate the end two of the cable, 1 millimeter, 1.8, 1.35, 1.85, 2.4, et cetera, et cetera. The latest version of Bullseye is targeted at 90 gigahertz. We've actually tested up to 110.
Oh,
So, when looking at 224 PAM4, great solution for testing that. We're starting to see the seedlings, I guess, of interest in 400 gigabit serial lane. So again, I purely conceptual, seems like pure science fiction, but
right.
once we get into 26 and 27, we'll be talking about the reality of 400 gigabits per lane. So, we've seen some testing capabilities from Keysight at 400 gigabit. We know that some of the IP providers, without naming anybody, are starting to look at that technology. And we are too, in terms of how we can test it with Bullseye and some of the performance we have with our Twin X cables. So that's just a little bit of a foregleam in terms of what we're going to be demonstrating or
Uh-huh.
talking about at DesignCon. We're really excited about the event. As always, Judy, it's always a good way to kick off. Like we mentioned earlier, it's always a good way to kick off the new year, looking at what the ecosystem is working on for the remainder of the year. So we're
Mm.
looking forward to it.
So this is sort of a fun part of this little annual podcast we do is this is where I ask you to put on your turban and get out your crystal ball. And with all the technology and the ecosystem development and speeds and frequencies and all this, what do you think we'll be talking about on this podcast in 2026?
Uh, AI. I mean, you can't
I
go
mean,
wrong
from
there.
now until
Yeah,
forever, that's all we're
yeah.
gonna talk about is AI for the
It
rest of our
seems
lives.
like it, but I think there's a large level of truth to that. So, AI in the data center obviously will continue to be a big topic. Something I saw just to kind of continue on that trend. I read somewhere that something along the lines of less than 5% of the global Fortune 1000 is actually using AI for their internal processes. So we've been talking about Gen AI, we've talked about inference, we've talked about training. We haven't really started talking about enterprise AI, right? How is it that these global
Right.
Fortune 1000 companies actually use the capabilities, the powers, harness AI to actually um, improve their processes so that they can drive value to the bottom line of the company. Obviously, the hyperscalers have figured that out because everybody's everyone's paying them for access to the AI.
Right.
But how, if you're a bank or if you're an interconnect manufacturer like Samtec, how do you use AI to improve your processes? We look at from a machine vision standpoint from
Mhm.
to look for manufacturing defects. But there's so many more like applications. So I think we'll see that becoming more and more of a reality over the next 6 to 12 months. A lot of the analysts in this space predict that there's been so much money that's been invested in AI capabilities. Companies aside from the hyperscalers are going to start to look for real ROI. So I think that's going to be a big thing. Um, we just mentioned 400 gigabits about how we're starting to see uh, seedlings of interest in
Right.
the technology. I think it's going to be more of an everyday conversation as we go into 26 a year from now. Will you see products at 400 gigabit? I don't think you'll see products before 27. That's just my opinion.
Okay.
But I wouldn't be surprised that, a year from now that we start to see people talking about, hey, we're going to have a 400 gigabit solution that does this. Um, you know, Ethernet, the entire Ethernet, like, excuse me, the entire Ethernet ecosystem. They're talking about 1.6 terabit per second port speed. When we get to 3.2 terabit, it's just a matter of time. And 400 gigabit technology will drive that. So I'd say those are 2 or 3 things I'd look forward to in
Mhm.
in the future. And then from Samtec's perspective, it's always going to be faster, smaller, denser. So that's our perpetual opportunity, perpetual challenge, and that's what makes us who we are. So we continue to answer the bell when our customers bring that to us, whether it's data center, AI, compute, or more traditional embedded industrial applications. So that's where I see us at 12 months from now, Judy?
I read something today just on LinkedIn where somebody was opining about photonics, and I think they're saying that they think there's going to be explosion of photonics startups this year. So I thought that was kind of interesting. What do you think about that?
It's inevitable. It's inevitable, that photonics are become more and more of a reality. Samtec is confident that copper has its place at 224, especially inside the box. We think for short to mid-range cabling, box to box, chassis to chassis, copper can play an answer. Can play it can provide a solution there.
Mhm.
Especially if you look at active copper. At 224 active copper, maybe you get 3 to 5 meters of length. But when you start getting out to 7 to 10, where you're linking top of rack, or you have to GPU clustering, you need optics to do it. The copper just can't make it. And frankly, it's the heat, it's the thermal response. Um, the photonics are just they weigh less because there's no weight there in the
Right.
fiber. There are latency issues. There's only a certain amount of length you can go uh, with the fiber optics and still keep the data rates that you need. But for most use cases, you only need to go 10 to 15 meters. So whether that's front panel to front panel, which is typically what we see now, or we start to see the transition to co-package optics. Broadcom has done some nice work on that. TSMC has done some nice work on that. This is all public, right? I'm not commenting on anything that hasn't been
Right.
publicized. Uh, I agree with the pundits that optics are going to transform this ecosystem. We don't typically look at co-package optics or front panel optics. We tend to look in midboard because they have some unique applications. But we think that we know there's niche applications in the data center for midboard optics as well. So again, just because of distance. So
Right.
that'll be something that we'll talk about more and more as time goes on. And I would be shocked if that's not a major messaging theme at DesignCon here come up in a few weeks.
Yeah, that's what I was kind of wondering about. I saw that and I'm like, I see these little blips on the meter. I'm like, huh, I wonder if that's going to show up at DesignCon. Again, because DesignCon often has novel bleeding edge stuff that you don't, and even our audience isn't going to see day to day, but it's helpful to track where we're headed and to sort of get educated up and do a heads up of where we're going. So it's kind of fascinating. Well, Matt, thank you again for your time. And welcome back to the new year and all the
Thank you.
challenges ahead. I appreciate everything you and all your team share with our audience. And I am going to put the link below for our audience, which is the Samtec DesignCon page, and that'll tell you where all the SI and all they have an amazing team of subject matter experts that are going to be presenting, and I'll put those links below so you can find them easily. So, Matt, thanks again, and I look forward to seeing you, if not at DesignCon, somewhere down the road soon.
Thank you very much, Judy. It's always a privilege, and I love getting on your platform and talk about tech. It's always a bunch of fun. Thank you so much.
Thank you. For our audience, thanks so much for joining Matt and I today. I trust you enjoyed this geeky conversation about AI and where technology's heading. Please go check out the show notes and check out Samtech's DesignCon page. I will be walking the floor. I'm not having a booth this year at DesignCon, but I'll be around and about, and I hope to see you there. We will see you next week in this continuing series. And until then, remember to always stay connected to the ecosystem.